We're up to lesson 4, which is where we'll build our first neural network using Pytorch. So this should be pretty cool. Just to review, what we saw so far, right, was our hypothesis function. And we said really our hypothesis function consists of two components, right? It consists of this linear layer, which is really just the dot product, right? Our weight vector dotted with our feature vector, plus this bias term, which kind of acts as a counterbalance. And if you think about what the linear layer returns, right, it returns any positive or negative number. And we said that basically the more negative the number is, the more confident we are in kind of a negative prediction, like there's not cancer. And the more positive the number is, the more confident we are in a positive prediction, like in this case that there is cancer. So this linear layer can output any number from negative infinity to positive infinity. And the next thing we do is we pass it through our activation function, which here we call this our sigmoid layer, right? This is the sigmoid function. And this is going to take numbers between negative infinity and positive infinity and turn it into values between 0 and 1. So the more negative the number is, that comes close to 0, and high positive numbers come close to 1. And if it's right in the middle, if say the linear layer outputs the value 0, then this just outputs 0.5 and basically isn't making a prediction one way or the other. And let's just see this. So these will be our feature vector, right? So this might represent a single observation, right, with a cell area of 3, cell concavities of 4. Oh, let's change this then. 3 and 4. And then this would be, that linear layer. It's just w dot x plus b, where we have weights. And we're just making these weights up. We're going to see how a neural network comes to these weights later on. But here we'll just set the weights at 2, 1, and negative 10. Same thing. This bias term is just made up for now. And then finally, we have this other layer, right? The sigmoid activation function, which we're using just with torch.sigmoid. And when we pass the data through these layers, we have x, and then we have the linear layer, pass through x, and that will be equal to z. Let's print out z, just so we see it. And then we'll pass this output from our linear layer into the sigmoid activation function. And it's 0 on the dot, which translates to a 0.5. Let's increase it a little bit. So this should be a higher positive number, which then will lead to a number closer to 1 here. Okay, so this is what we built, kind of essentially by hand. And to translate these same layers, our linear layer, into using Pytorch with a neural network, we'll do the following. So this is our linear layer and our activation layer. So here we'll do import torch.nn as nn. So nn stands for neural network, and we say as nn. We're basically assigning this module, this library, to the variable nn. And now we can just reference it as nn, right? So you can see that here, this is this module from Pytorch. And to build a neural network, we'll use the sequential function. I don't even know. So this is kind of the wrapper for our neural network. And if you think about what our neural network consists of, it consists of a linear layer. And we'll say, we'll see what these numbers mean a little bit. Let's just use them for now. So this is our linear layer, followed by our sigmoid layer. And we'll assign the whole thing assign this whole neural network as net, and then we'll just create it. And you can see it's printing it out pretty nicely for us, saying this is our first layer, 0, and this is our linear layer, and this is our second layer, sigmoid. And now, just as before, we kind of passed through this feature vector to our linear layer, to our sigmoid activation function. We can do the same thing here. We can start with our feature vector. Just delete this. And what we can do is take the net and pass through the feature vector to this neural network. And look at that, we get an output between 0 and 1, just like we do when we use our stuff by hand. All right, so let's now understand these components a little bit better. First of all, like you can actually, if you go to the neural network, you know, this is like a list of layers. So I think you can actually access, if you want to, like access the first layer just with the square brackets. And then from here, I think I can type in parameters. And you can kind of see what's here. It's interesting. We have both our weights and our bias. Let's even take a look at that. So net bracket 0 to access my first linear layer. And I could even just probably do weight. And you see this? This is returning to us a vector of the weights, just like we had before, right? Remember previously we had a weight vector, which was torch.tensor, and we just made them up. And here we're seeing the ones that Pytorch used. And we can do the same thing with the bias term. Just do net bracket 0 dot bias. All right, and there it is. And what happens when we, you know, if this is our linear layer, I'll just create a new one outside of a neural network. So this is my linear layer. And you can see here's the parameters. And when if we were going to like pass through a vector x, 4 and 4, into this linear layer, what do you think occurs? Like what occurs is the dot product, okay? So when we're passing through x into our neural network, the first step that happens is the dot product, and that returns a number between positive infinity and negative infinity. And the second thing that happens is we take that value, that output from our linear layer, and pass it through the sigmoid function to squish it down between 0 and 1. So that's the same thing that happens here. Like, let's just show you this. If what I'm saying is right, then this is my weight vector, right? And my bias vector is this, torch.tensor, or I should say my bias is this value. We'll just use the number right now. And then I should be able to do w.x, these values, plus b, and get this value. And then if I do this linear layer thing, we get the exact same value, all right? And then if I take this value, this is my z, and I pass it through this, you know, the next thing I did was nn.sigmoid, right? This is my sigmoid, and I can do the same thing. We can either, you know, do torch.sigmoid, kind of like we saw before, and pass z through there, and get back an output now, right, between 0 and 1. Or we could just kind of do this by hand and say, okay, here's my neural network .sigmoid. So you create it, and then you assign it to this like any variable you want. You just call it sigmoid, and then you just pass through z. So the point is that what's happening under the hood when we do something like nn.sequential, nn.linear 2, 1, comma, right, nn.sigmoid, is it's just doing exactly the same operations that we saw previously. w.x plus b, where w is, you know, a tensor of length 2, and just maybe like that, and b is just, you know, like a bias term, like 5 or something, or negative 5. And then this is our sigmoid function, okay, which we saw before. So it's literally just passing through our data, that feature vector x, through this. Now, here's a couple things to point out. This feature vector, well, if you looked at it, let's look at this again, is, let's just look at the weight vector, sorry. It's of length 2, why is it of length 2? Well, we specified that it should be of length 2 right here. Okay, so we're always just going to have this equal, or we want to do the dot product. That means we're pairing up each entry in our weight vector with a corresponding entry in our feature vector. And so if this is of length 2, that means this should be of length 2. Okay? You can see also we specify like a 1 there. We'll get to that in a second. But for right now, the other thing I want to point out is you might be wondering, okay, so we specified the length of this, but where are these random numbers coming from? And I guess I gave it away. They are random. So you can see every time I create a neural network, we are generating starting off with new random numbers, new random weights, and even the bias is also random. This will just change every single time, all of these 3 numbers. Okay? So what we'll see in the future is that our neural network will start with the random numbers and then learn, the best ones essentially that predict our data. But we'll get there. So that's one thing to show you. The other thing I wanted to show you is, okay, so if the 2 is specifying the length of the feature vector, what is this 1 specifying? And the 1 is essentially specifying that we're going to have a single neuron in this layer. And we don't really know what it means to have multiple neurons, but maybe we can just show you. If I change this to number 3, see that? Now we have 3 weight vectors, and we also will even have 3 bias terms. See that? So, when we went back to 1, we just had 1 weight vector and 1 bias term. So we're going to see later in later lessons what that means, but I just wanted to show you for now, you can kind of get a sense. All right, for now we want to have a weight vector of length 2, and we want to just have 1 of them because we're just working with a single neuron. And that may be it that I wanted to show you guys. Yeah, the only last thing maybe to show you is for teaching purposes, remember, because these are random weights every single time, so every time these weights are going to change. If you want them to stay the same, say I want that the numbers I'm working with are exactly the same of the numbers that you're working with, you can set this manual seed value. So I can and just pass through a number like 2. And as long as this number is the same in my notebook as it is with your notebook, the generated pseudo-random numbers will stay the same. See that? This time they are not changing. They're always the same. But if I take this out, now they're changing every time. All right, so this is torch.manual seed. So that's it. If you create a neural network, just to review, well, we basically are just creating our linear layer followed by our sigmoid layer. And the way that we do that is we wrap everything in this sequential function. Then we do nn.linear. Sounds good. We specify the length of the weight vector as 2, and followed by the number of neurons that we want, and that's 1. Then we put a comma, and the next thing we do is say what layer comes next. For us, it's the activation layer, that's sigmoid. And then we'll assign the whole thing as net, and finally, if we want to, we can pass through our feature vector, our feature vector, x, which represents, the cell area, cell concavities of a single observation, and we want to predict whether or not this is cancerous. And here it looks like if this prediction is non-cancerous, but of course we know that it's using random values to generate this prediction. So in the future, and really the next set of lessons are all about learning those values, okay? How does a neural network learn what is the proper weights, what is the proper bias terms? And we're going to start with that again with just doing this for a single neuron. So we'll see this next.